Hi guys, today we will discuss matrix method based circular convolution. Okay, personally I will refer to solve the problem using a matrix method based. It may be an DFT or circular convolution or linear convolution. Just practice to solve the problem using a matrix method based. It is very easy when compared to the graphical method and other methods. Okay, so let's see how to solve matrix method based circular convolution. Let x of n and h of n, okay, um, let x of n and h of n are two sequences. Actually these two variable representation we will use in the filter design. Okay, we will discuss later. Okay, actually what is this x of n and h of n? Right now just understand these are the two variables we are using to represent the two sequences, because here we are convolving two signals. Okay, that is x of n and h of n are the two sequences of length n. Okay, of length n. Usually you know very well the representation of endpoint circular convolution. The symbolic representation is inside the circle we will denote n, capital N. N represent endpoint. Okay, endpoint. Here it is an endpoint circular convolution. Okay, so here we are mathematically represent the circular convolution. Okay, like this: y of n is equal to x of n, circular convolution of n point with the h of n, right? So here the small n varies between 0 to n minus 1. Okay, small n varies between 0 to n minus 1. Okay, so here we will solve one problem. Okay, so matrix method based circular convolution. These are the two sequences. Okay, one is x1 of n, another one is x2 of n, right? So obtain the circular convolution of x1 of n with x2 of n. This is x2 of n. Okay, these are the two sequence. X1 of n is convolved with the sequence of x2 of n. Okay, here see that here they have not given any, it is a 4-point sequence, these things. Okay, so once if you are seeing this sequence, okay, you have to determine what is the sequence length, how many points we have to find out the circular convolution. Okay, 1, 2, 3, 4. It is a n is equal to 4 point, right? It is a 4-point circular convolution. Okay, so how we will represent the sequence? Usually small n is varies between 0, 1, right, 2, 3. Similarly this is also 0, 1, 2, 3. Okay, these are the two sequences. This is the mathematical representation of circular convolution of x1 of n and x2 of n. Here the capital N is 4. Okay, so here we are representing the discrete, n is a discrete time sequence, right? 0, 1, it is as it is a 4-point circular convolution. So n varies between 0 to 3, right? This one is a x1 of n. This is x1 of n. Okay, this one is a x2 of n. This is a x2 of n. So we are convolving these two sequences, right? So we are here, we are representing x1 of n as a 4 cross 4 matrix, right? So we will get 16 values. 4 cross 4 means 16 values. This is a n cross 1. N means 4 rows, right? 4 rows, 1 column. You know very well how to represent 4 cross 1. This is a 4 cross 1. This is a 4 by 4 or 4 cross 4 matrix. Row into column, right? Row into column, isn't it? So how we are representing, see here, the x1 of sequence is 1, 2, 3, 4. So we are representing in the column wise. Okay, 1, 2, 3, 4, right? X, x1 of 0, x1 of 1, x1 of 2 value. This is a x1 of 3 value. See here, this is x1 of 0, x1 of 1, x1 of 2. This is a x1 of 3 value. Okay, so we are representing in a column wise. Okay, thereafter what should we have to do? So just we have to transfer this one to the next column, right? It is a second row, right? This is a second row. So here we are transferring this one to here, this to here, this 3 here. Then this 4 goes to the first row of second column. Similarly, 1, 2. This 3 goes to here. This 4 comes here, okay? 3, the last row of the second column goes to first row of the third column, right? Similarly, 3, 4, 1. The second goes to last column of the first row, right? That's all, right? So here I have taken x1 up. Ma'am, you will also get the doubt, right? Ma'am, shall I take extra of 1 like this? Yeah, you can also take. Okay, you can also take as that sequence as a 4 by 4 matrix, right? Here there is no particular rules and regulation. You can take any of the sequence as a 4 by 4 matrix, right? Here I have taken x1 of n as a 4 by 4 matrix. Extra of n I have taken as a 4 by 1 matrix, right? So I have written as a column wise, right? See here, this is a extra of n sequence 1, 1, 2, 2. That's all. Okay. Now we have to do multiplication. We have to do these two matrix multiplication. You know very well how to do matrix multiplication. Okay. I will show you how to do the matrix multiplication for this problem. See here how to solve this matrix. Okay, see here we have to take this first row, we have to multiply with this column. Okay, you see here 1 into 1, right? 1 into 1, 1 cross and 1 ones are 1 plus, okay, 4 ones are 4 into 1. So we have to multiply this 4 with this 1. 4 into 1, 4, right? Plus this 3 we have to multiply it with 2. 3 by 2, 3 into 2, 6 plus, right? 2 is multiplied with this 2. 2 by 2 or 2 cross 2, 2 into 2, 4. Just we have to add all these values. So 6 plus 4, 10, 10 plus 4, 14, right? 14 plus 1, 15. So you got this number. Similarly, you have to solve the x1 of x3 of 1. This is the output of what is x3, right? x3 of 0. x3 of 0 is what? 15, right? Similarly, you have to solve other three values of x3 of n. So x3 of 1 value, how can we solve? So you have to multiply this sequence with this sequence. Okay. So 2 ones are 2 plus, right? 1, this one. 1 ones are 1 plus. So 4 twos are this one. 4 twos are 8 plus 3 twos are 6 is equal to, just add these values. So 8 plus 2, 10 10 plus 6, 16, 16 plus 1, 17. You got x3 of 2 value is 17. Similarly, you have to multiply this row with this column, right? See here, 3 ones are 3 plus 2 ones are 2 plus 1 twos are 2 plus 4 twos are this 4, this 2. 4 twos are 8 is equal to, just add these numbers. So 2 plus 2, 4, 4 plus 3, 7, 7 plus 8, 15, right? So you got x3 of 2 value. Similarly, you have to solve this last row with this column. So 4 ones are 4 plus 3 ones are 3 plus 2 twos are 4 plus 2 ones are 2. Just add these numbers. So 4 plus 3, 7, right? So 7 plus 4, 11. 11 plus 2, 13. You got the last value of x3 of n, that is x3 of 3. So this is the circular convolution of x1 of n and x2 of n. So the result is x3 of n, right? The result is x3 of n. So usually you will get this question for 5 marks. Sometimes they will ask for 8 marks also. Okay. See, do this at your home. Okay. Obtain the circular convolution of following sequence using matrix multiplication method. They will ask directly, use matrix multiplication method. So they have given the two sequence. You can take any of the sequence as a 4 by, what is the sequence here? 1, 2, 3, 4, 5, 6, 7, 8. Here 1, 2, 3, 4. This is 4, 8. So here the end point is 8, right? So here you have to do 8 by 8 matrix. So they won't ask this much length in the end point sequence for 8 as a 8 point. The length of the sequence should not be more than 4. They won't ask in the exam. Don't worry. Just for practice, do the circular convolution for endpoint 8. Okay. So this is another question. Usually in order to confuse you, okay, in order to confuse you, they will ask the question like this. They won't give the sequence directly as like this. Okay, they won't give the sequence directly like this. Okay, sometime they will ask the question like this. So you have to find out the sequence for this extra of it. How should we have to find out, ma'am? Just you have to supply. This is as it is a 8-point sequence. So just you have to apply the value of n, right? So the n value is varies between 0, 1, 2, 3, 4, right? 5, 6, 7, right? So you have to apply the n value here, right? The n value here, the pi is radian. It should not be degree. Okay, it should not be 180. It should be radian, right? You know what is the value of pi? 3.14. Just use the calculator. Without calculator, you can't solve the problems of DSP. Please keep one calculator along with your higher end version. Okay, then only you can easily solve the problem within a short duration. Okay, so just substitute the value of n first. Extra of 0 value, you have to calculate extra of 0 value. Okay, I will show for this value. Okay, so just apply the n value as a 0. You know very well. So sign of 0 is 0, right? We'll get that value. See here. So extra of 1. So you have to substitute the n value 1, right? Use the calculator and find out. You will get this 0.923. Similarly, you have to calculate up to 0 to 7. Okay, you have to calculate up to 0 to, this is 7th value. Okay, 0 to 7. Then afterwards, as usual, you can do matrix multiplication method. So you can apply matrix multiplication method. This is 8 cross 8 matrix. Okay, 8 cross 8 matrix. So you have to multiply these two matrix. You will get this. Just verify whether this answer is correct or not. Please solve this problem at your home. Okay. In the next video, okay, we will discuss how to solve the circular convolution using a DFT IDFT method. Okay, hope you will understand this problem, right? Matrix method based circular convolution problem. Okay, have a great day. Thank you very much. Happy learning.